Yes. So I came across this Leetcode challenge. Looks very interesting. Um, so basically you are given a string like this, and you are to look for every possible valid combination that's going to form an IP address, right? An IPv4 address, right? So looks very good, and there are some good assumptions that the string is always going to contain numbers, and it's never going to be more than 20 characters. So a mind map came to my mind. Here's what I'm thinking. What I'm thinking is go through the string and create a tree, right? So, for example, in this case, we'll have a pointer on this first digit, and we'd say, is this a valid octet? If so, we can keep it. If then we add one more, the next character to it, and we say, okay, are you a valid octet? If it's still valid, we have a new node, a new leaf or a new node. Then we add again a third time, which is the last time we're going to add to it, and we check if it's still valid. If it's still valid, we create this node. If it is not, we won't create this node, right? Um, 1 minute. I'm back. Okay, I'm back. I'm sorry about that. So yeah, yeah, if it wasn't valid, you won't create a new node, right? So then you would when we have that, you try again for the next set of characters. So in this case, when we have 255, we went to the next character, then create a new leaf under 255, and we go on like that, and we keep going on. So after 255 again, there was a 1. You have the 1, there was 1 1, then 1 1 1, right? And you keep moving that way. Then when you form your tree, after forming the tree, we can traverse every single leaf and try to find the best possible match. Like not the best possible match, a valid IP address from the tree. So that's basically what we're trying to do, right? Um, so in that case, that would mean every to traverse the tree and get only four nodes, and the last node must be a leaf. So if the first four and the last of the first four is not a leaf, then it's not valid. Just like this guy, 1 2 3 4. This is not a leaf, it's a node, then it's not valid. But this is a leaf, then this is valid. So those are the two valid conclusion, right? So that's what my mind map is. I'll be right back again. 1 minute. Okay, I'm back. So I wrote a bit of code to create that tree, just like visualized, right? So we have this struct type, which is a node, and it has two properties, right? That's the octet. And what I mean by octet is just the value of that node, and the kids, the children, them babies. Then I also added some extension to the substring class. You see why I did that later on. So yeah, but this is the pass function, and what this function does is you give it that string, like in the visualization, right? And it's to create you a tree that is going to go 2 2 5 2 5 5, and keep going like that till you have the tree of a tree of every possible octet combination. So if you see the code straightforward, oh, I even don't need to do this. I can just do because like Swift says the function parameter is a constant. So, but if I use a var, I can make it. I can make it variable. It's not a constant. Um, so I range 3 times. Keep checking. You do a substring and you check if it is a valid octet. So if is 2 a valid octet, yes. Is 2 5 a valid octet? Yes. Is 2 5 5 a valid octet? Yes, as well. So That's what this code is basically doing. And if it's valid, you do recursion, right? You keep going and create your tree. So now we're going to write a function that's going to traverse the tree. And the function is basically going to do the same thing this guy is doing. It's going to be a bunch of recursion as well. So let's write that function. So I really don't know what to name this guy. Short of names. Maybe I should call it gather or traverse. Oh, yeah, since the creating the tree is pass, probably I should call it pass. Maybe that's a good name. So on pass, and what we're going to do here is on pass we take the node, right? Um, Let me call it head, and it's also going to take a prefix, right? So, and the reason for that you are going to see, and it's going to return a list of IP addresses, right? Okay, so let's create that list of IP address and return it. Um, okay, just thinking. Yep. So we need to create the next prefix. So say our next prefix is going to be this prefix, right? Plus the current head octet, right? But that's only if the octet, because the octet is an optional, so we need to. It can only be done if there is something, if there is a value. So if there is no value, the prefix should stay the same, right? So we can just do like this. What? Okay. Prefix dot. Most times there should be a dot. Yeah, do it this way. Then just leave it as prefix if there is no octet, right? Okay, I probably need to force this guy. Okay, so that's the next prefix. So we can now say, okay, for every kid, right? For every child and children, we need to call, we need to recurse, right? So we do on pass prefix, obviously prefix, next prefix rather, and this is going to be the child, right? And it is going to be the children. Okay. So and this is meant to return a list, right? Okay. So and at the end, like, yeah, we need to now like merge the list, right? But first, let me see what this error is saying. I need to name this guy. How do we merge lists in Swift? That I don't know. Oh, so you can just do with the plus operator. Fancy. Just like Python, right? So you can do plus L. So we don't even need to do this guy. We can just do it directly, right? Yup. So yeah, I probably need to give this a signature since the compiler can't infer. So another thing we need to have a base case, right? And that base case would be when there is no kid, because now this is just going to run and crash when the the call stack is full. Um, so what will be our bit case is going to be when there is no more kids, when we're on the leaf node. So if the children that count is equal to 0, right? Then we should return next prefix instead. Yep, next prefix. So we can probably even, yeah, this is okay. I think this is okay. Probably I should even drag this down. I don't know if there's any memory benefit to this, but probably the compiler is smart, but let me just leave it this way. So I think if I do this, now we're going to get a list of, we should get a list of very, very shitty IP addresses, but very, very invalid IP addresses. But you know what? Let's just test it out. All right, so if I unpass this tree and I get L equal to this, and I print L, let me see what happens then. Guys, I don't think it's working. Oh, it is. Okay, yeah, so now we can see I get a bunch of. So this is a correct IP address. Definitely this one is wrong because it is 1, 2, 3, 4, 5 octets. But this one is 4 octets, so which is right. This one is 5 octets. So we need to filter every 4 octets. Every 4 octets. So, or what we could do is we could also like when traversing the tree, we can stop when we've hit a depth of 4. So that's one option. So we can either, what the first option is we can either like in our pass, instead of going all the way down for every possible combination, we can stop when we hit the 4th guy. And if there is still kids after the 4th guy, then we return an empty array from that call. Yeah, so how do we do that? We do that, we can do it here. We can say like we want to count the amount of dots in the next prefix. So if we have 1, 2, 3, 4, then it's valid, right? But if we have more than 4 at this point, we don't want to return anything anymore. So we should probably do it below this guy. So how do I check if a string has, multiple strings in? Oh, so you can use this count that receives a closure. Okay, nice. Nice. Let me correct that. Okay. Nice. Okay, so what does count return to us? It returns an integer. Okay. Yep, so we can just say count where the character is equal to dots, right? So then we'll say this is our level. Let's level depth What's the error now? Is that it? Okay, that's it. So we can say if depth is greater than or equal to 4, should return an empty array. Right. And we can even like just make it short and right. So let's try this guy. What does the compiler have to say? Ah, come. Let me just leave it the way it is. Yep. So, yep, exactly. So now we get the two valid IP addresses. So, but we need to do one more thing, right? I need to remove this ugly dudes, ugly last dot. Probably we should do it here. Probably we should do it here. We probably need to check this next prefix, right? So, can do. Does next prefix have the last item? Does the last item? Yeah, let's do that. Next prefix dot index. So I can just do next prefix dot end index, right? So yeah, so if the next end index is equal to a dots, we return next prefix before the end index. So it's going to be a range, right? And else we just return next prefix. But most times the prefix should always have the end, right? What does the compiler have to say? Ah, yeah, it has to be a string. It's a string. So now this was the reason I added those extensions to substring. So to string was one of them. So apparently, whenever you try to slice a string in Swift, it creates you a substring. Don't know what they mean by that, but yeah, that's smarty pants. So let's see if it removes it or if I've broken. Yeah, I've broken the software. I think it's because like some strings are going to be empty, or do I have to do? Yeah, I don't think it's. I think it's my. It's this guy. So this range, if we say, you know what? Let me just use the Swift repo. So if we copy this, if we save our s is equal to 255.255.111.35 dots, right? And we say s all the way to s dot end index. Ah, if I do this, it's going to crash. So I need to do like -1, but I can't deduct an index because index is different from an integer, right? So I can't do -1. Yep. So if I wanted to do this, I probably need to do s dot index and say before s dot end index. Would that work? What? Then offset by -1. Ah, no wait. What? Oh, so it actually worked. I need to convert it to a string. So yeah, before um before this guy, and we say let's just call it a string. Exactly. So I need to do, but if I had just done the way I'm doing it currently and say, yeah, so why was it crashing? It's probably this guy as well. Probably I should just do a simple if check. If next prefix that counts greater than 0, but up, you know, s, so s that count is greater than 0, right? Let me just write a print here so I can know why exactly this is crashing. Probably there's a better debugging. Ah, yeah. So I can't do this. That's to be like -1, right? Yeah. So probably have to do this. Let's last index. I should probably even maybe this is better. Okay, so let's try this guy. Yeah, it does exactly what we want, so I'm good to go. So now we just need to call our functions inside of Leetcode, right? So let me just copy this whole thing, right? You know what? Leetcode. Yup. Do I really need foundation? I don't think so. So I could just do pass, right? I could pass and create a node. Node. then I'll pass add prefix going to nothing, pass it, and done that instead. See how that goes. I run this. Aha. 0 is a case, is a base case. So the first case passes, the 0 case obviously fails. And that's because I'm not removing numbers with invalid amount of octets. So I still need to filter at the end of the day for that one. For this one, what could be wrong? Yes, so it's the same thing as well. So I need to start filtering. I need to still write a filter at the end of this. So let me go back to my terminal. You know what? Copy this guy. Yep, so let's do that filter. And what's the predicate? So the funny thing is, it's going to be a nested closure, right? Let's count, like I don't think I can use, let me just do count C in C is equal to dots. Then we're going to return it if it is equal to 4. So we only want the ones that have not for 3 dots in it. So if we do this, we should get exactly what we need. I'll just copy this bit and go back to Leetcode and paste it. Yup. Okay, now the first 2 cases passes. What in the bloody hell is this case? So we have, so this, they can't begin with a 0. So can't begin with a 0. Okay, so what I need to do is update this. This is valid, right? I need to check if the string has more than 1 character. And if it has more than 1 character, the first character cannot be a 0. So let me go back to my terminal. I just prefer writing into my terminal because I have this JK and I don't have JK keybinding. In Leetcode, I don't know how to set it up. So I should probably do if self.count greater than 1 and self.count self.start index is equal to 0. We should return false. Probably invalid, right? Okay, so if I go back to this code and I add that here and I run it, does it solve my problem? It does. So let me submit it. Hopefully there is no other weird case that doesn't make this work. Ah, accepted. Correct. So that's it. That was the challenge. The challenge just caught my eye. It felt interesting, and I thought, let me make a video solving it. All right, cheers. Bye bye.